Hello friends, myself R.D. Mahajan presenting my video on inverse Laplace transform revised. Definition of inverse Laplace transform is if Laplace of f of t is equal to f bar of s, then inverse Laplace of f bar of s is equals to f of t. By transferring this operator to right hand side, we get inverse Laplace of f bar of s as f of t. Then we try to see some standard result for inverse Laplace transform. The first one, inverse Laplace of 1 by s is 1. Second, inverse Laplace of 1 upon s minus a as e raised to at. If here we have minus a, then we get e raised to at. Or if we have s plus a in the denominator, then we get e raised to minus at as the inverse Laplace transform. Then third, inverse Laplace of 1 upon a square plus a square as 1 by a sine of at. Then fourth, inverse Laplace of s upon a square plus a square as cos at. We know this Laplace of cos at as s upon s square plus a square, and therefore we get inverse as cos at. Then next, fifth, inverse Laplace of 1 upon s square minus a square with the condition s greater than a. Its inverse is 1 by a sine hyperbolic at. Then sixth, inverse Laplace of s upon s square minus a square as cos hyperbolic t, cos h at. Then seventh, inverse Laplace of 1 by s raised to n. There are two different formulas to find inverse of it depending upon the nature of that n. If n is positive integer, then its inverse is t raised to n minus 1 divided by n minus 1 factorial. If n is positive integer, if n is positive integer, and then or we have another value for first example. Find inverse Laplace of 1 upon 7s. Using that standard result, inverse of 1 by s is 1. For that, we have to take that constant term outside. Therefore, 1 by 7 outside. Inverse of the remaining term is here 1 by s. And inverse of 1 by s, just we have seen, its inverse is 1. And therefore, 1 by 7 into 1, we get that value as 1 by 7. Second, find inverse Laplace of 1 upon s plus 4. It is 1 upon s plus a type of term. Its inverse is e raised to minus at. A is here 4. And therefore, as here plus 4, the term is e raised to minus at. Therefore, inverse Laplace of 1 upon s plus 4 is e raised to minus 4t. Then third, find inverse Laplace of 1 upon s minus 9. Here the term is 1 upon s minus a, and whenever we have such type of term, its inverse is 1 upon s minus 9, inverse of that term, as e raised to 80. A is here 9, and therefore it is e raised to 9 times t. Fourth, find inverse Laplace of 1 upon s square plus 25. 25 is 5 square. 1 upon s square plus a square, its inverse is, therefore, inverse of 1 upon s square plus 5 square as 1 by a is here 5, therefore 1 by 5, sine of 80, a is 5, therefore sine 5t as a required value or required inverse Laplace transform. Find inverse Laplace of s upon s square plus 16. 16 means 4 square, and therefore by the standard result, inverse of s upon s square plus 4 square as cos of 80, a is here 4, and therefore it becomes cos of 4t as the required value. Then sixth, find inverse Laplace of 1 upon s square minus 9. Here is 3 square means 9, and therefore inverse Laplace of 1 upon s square minus 3 square as per standard result, it is 1 by a is here 3, therefore 1 by 3 sine hyperbolic, as it is s square minus a square in that form, therefore sine hyperbolic of 80, a is here 3, therefore sine h 3t. Find inverse Laplace of s upon s square minus 36. 36 means 6 square, and therefore by standard result, inverse of s upon s square minus 6 square as cos hyperbolic 80, a is here 6, therefore 6t. Next example, find inverse Laplace of 1 upon s cube. Here the power 3 is positive integer, and therefore using that standard result, we get inverse of 1 by s cube as t raised to n minus 1, t raised to 3 minus 1 divided by same factorial, that is 3 minus 1 factorial, and therefore we get that value as t square divided by 2 factorial. 2 factorial is 2. This is the required answer. One more. Last example. Find inverse Laplace of 1 by s raised to 3 by 2. Here the power n is not positive integer. Therefore we have to use that corresponding result to find inverse. 1 upon s raised to n, if it is not positive integer, as t raised to n minus 1 divided by gamma of gamma n. And therefore, inverse Laplace of 1 by s raised to n as 1 by s raised to 3 by 2 as t raised to 3 by 2 minus 1 divided by gamma of 3 by 2. And whenever we require to find the value of gamma, try to express in the form of n plus 1. And therefore, this is t raised to 3 by 2 minus 1, 3 minus 2, that is 1 by 2, and divided by gamma 3 by 2 we can rewrite as gamma of 1 by 2 plus 1. 1 by 2 plus 1 nothing but 3 by 2. And then we have the standard result gamma n plus 1 as n gamma n. And second value gamma of 1 by 2 as root pi. And therefore, applying that two results, we get that value as t raised to 1 by 2 whole divided by 1 by 2 gamma 1 by 2. And then substituting the value of gamma 1 by 2, this 1 upon 1 by 2, that 2 goes to numerator, therefore it is 2 t raised to 1 by 2 and divided by gamma 1 by 2 is root pi as the required answer. Therefore, here I have explained one example for each standard result. In my next video, I will discuss shifting theorem to find the inverse Laplace of f bar of s. Therefore, if you like my video, please share it, as well as subscribe to my channel if you are not subscribed yet, and press the bell icon to receive the notification for my such type of all new videos. Thank you. Thanks for watching.